Question 2, lots to do here and not a particularly pleasant formula to start with, have we? I'm just being careful writing it down because there's lots of brackets there and I just want to make sure. So it's the ln of t plus 1 times by all of that. And it's asking us to start with where a and b are. And of course that's at v is equal to 0. I'm not going to write it again. So there's two choices. Either this bit here is 0, the ln of t plus 1 is equal to 0, and of course the ln of 1 is 0, so that gives you t is equal to 0, or the other part is this one here equals 0. So 10 take away a half t plus 1 is equal to 0. So that's t plus 1, and add that on and times by 2 in 2 lines there is 20. So I've got t is equal to 19. So I've got two places where the coordinates of a and b are 0, 0 and 19, 0. That's part A. Now for part B, we need to differentiate it. So we've got a product rule. These two things are being times together. So we've got u is this bit and v is the ln of t plus 1. We've got to be careful differentiating each of these, haven't we? So look, you know the 10 is going to differentiate to 0. You know that bit's going to differentiate to 0 as well. So we've just got the number of t's there. I've just got minus a half. And this one here, dv by dt here, the ln goes to 1 over t plus 1. And so I don't like using v again. I've used v there and v there, but which is a bit annoying. But I've kept my wits about me, so I'm okay. It's these two things times together, so I've got minus a half the ln of t plus 1 plus these two things times together, so 10 minus a half t plus 1 all divided by t plus 1. That's pretty grotty. Look, we could actually tidy that up, would make it a little bit nicer, wouldn't it? What you mustn't do is think you can just cancel those two things there. But I think I'll rewrite that as this plus 10 over t plus 1, so that's that bit, and then minus, just these two bits will cancel out then, so just then minus a half. So that is f dashed of t. That's part B. So with that bit done, now part C says show that the stationary point is between 5.8 and 5.9. So that means sticking the 5.8 into all of this and the 5.9 into all of this, and they're going to be either side of 0. So this one's 0.0121, this one's minus 0.0164, change of sign. Therefore, f dashed of t has a root or equals 0 between 5.8 and 5.9. Okay, so that's part C. You're going to ask us to Newton Raphson this now? No, we're not Newton Raphson it, thank heavens for that, because that would be differentiating again, wouldn't it? What we are doing is putting 0 in here and actually going to try and algebraically rearrange this. So this is, we've got that. Right, let's times it all by 2. That's the start. And why am I doing that is I can see there's a 20 in there. So I've got minus the ln of t plus 1 plus 20 over t plus 1 minus 1. So what I did there was times by 2. Let's add these two things to this side here. So I've got 1 plus the ln of t plus 1 equals 20 over t plus 1. I'm going to times that up and divide that down, so just switch those two over. So 20 over the ln of that, can you still see that? Equals t plus 1, and the last thing to do there will be take away the 1 from both sides. And so t equals 20 over 1 plus the ln of t plus 1, take away 1 as required. So for the last part here, it says our first guess is going to be 5. Stick the 5 into all of this, and that gives me my next guess is going to be 6.1639. Then I'm just pushing equals on the calculator each time now. So I've got 5.736, and my third one I've got 5.879. And I'll round those to round that, and I want that 3 decimal places. Is that okay? There you go. 6.164, 5.36, and 5.89. Good, got that.